Lecture 1: Drilling Operations Sequence in Offshore Environment. Offshore drilling involves a structured, carefully controlled sequence of steps from spudding the well to final completion. The objective is to reach the target reservoir safely while maintaining structural integrity and avoiding environmental hazards. 1.1 Planning and Preparation. Site survey, bathymetric mapping, seismic profiling, and hazard identification. Rig mobilization, transportation and setup of offshore drilling rig. Permitting and regulations, environmental assessments, licenses, and documentation. 1.2 Spudding the well. Spudding refers to the initial stage of drilling, where the conductor casing is set. A spudding pile or drill template may be used for deepwater subsea locations. 1.3 Drilling and casing. Riser installation. Marine risers connect the drilling vessel to the seabed. Drilling with mud circulation maintains pressure, removes cuttings, and cools the bit. Casing programs: surface, intermediate, production casing set and cemented. Logging while drilling (LWD) and measurement while drilling (MWD) tools monitor formation properties in real time. 1.4 Well logging and testing. Wireline logging for formation evaluation. Drill stem testing (DST) to determine reservoir pressure, productivity. Lecture 2: Offshore well control operations. Well control ensures that formation fluids do not enter the wellbore uncontrollably, which could lead to a blowout, a catastrophic failure. 2.1 Primary well control. Mud weight management, maintaining hydrostatic pressure above formation pressure. Kick detection systems, pit gain, flow rate increases, or changes in pump pressure. 2.2 Secondary well control. Blowout preventer (BOP) stack closes the well if a kick occurs. Components include O-annular preventers, O-ram preventers, O-blind shear rams for emergency shutting. 2.3 Tertiary control. Capping stack or relief well in case the primary and secondary methods fail. 2.4 Offshore considerations. Subsea BOPs require remote operation via ROVs, remotely operated vehicles. Pressure-temperature effects at depth must be considered. Well control simulators are used for training personnel. Lecture 3: Subsea well completions. Subsea well completion is the process of making a well ready for production in deepwater locations without surface infrastructure. 3.1 Subsea well completion basics. All equipment is located on the seabed. Subsea trees control the flow of hydrocarbons. Tubing hangers, annular seals, and production tubing are installed subsea. 3.2 Types of subsea completions. Dry trees, surface completions used on platforms or TLPs. Wet trees, subsea completions installed directly on the seabed. 3.3 Completion steps. Set production packers to isolate zones. Run production tubing and connect to subsea tree. Install subsea control modules, SCM. 3.4 Advantages. Reduce surface footprint. Can be used in ultra-deep water. Ideal for tiebacks to existing platforms or FPSOs. Lecture 4: Subsea Production Systems, an overview. Subsea production systems enable long-term extraction of hydrocarbons from beneath the ocean floor without the need for permanent surface facilities. 4.1 Components of subsea production systems. Subsea trees, valve assemblies that control flow. Manifolds, combine flow from multiple wells. Flow lines and risers, transport fluids to surface facilities. Control umbilicals, deliver hydraulic and electrical power to subsea systems. Templates and structures, provide mechanical support and guide installation. 4.2 Types of subsea systems. 1. Step-out wells. Or individual wells tied back to a host. 2. Cluster systems. Or multiple wells connected to a central manifold. 3. Daisy chain systems. Or sequential linking of wells to reduce infrastructure. Lecture 5, Control Systems and Monitoring. Remote operation of subsea systems is enabled by control systems that ensure safety and efficiency. 5.1 Subsea Control Modules, FCMs. Contain electronics and hydraulics to operate valves. Communicate with the surface via fiber optics or hydraulic lines. 5.2 Monitoring and Diagnostics. Sensors monitor pressure, temperature, flow rate. Condition-based maintenance using real-time data. Data loggers track equipment behavior for future analysis. Lecture 6, Flow Assurance and Challenges. Flow assurance involves ensuring the uninterrupted and economic flow of fluids from the reservoir to the surface. 6.1 Flow Assurance Challenges. Hydrate formation, ice-like structures that block flow lines. Wax deposition, solidifies inside pipelines, reduces flow. Slugging, intermittent flow causing pressure surges. 6.2 Mitigation Techniques. Insulation and heating of pipelines. Chemical injection, methanol, inhibitors. Use of pigging tools to clean pipelines. Lecture 7, Intervention and Maintenance in Subsea Wells. Regular maintenance ensures long-term performance of subsea wells. 7.1 Subsea Intervention Techniques. Light well intervention, LWI wireline or coiled tubing via riserless systems. Heavy well intervention, uses risers and may involve walkover rigs. ROV support, for inspection, valve operation, and diagnostics. 7.2 Maintenance Strategies. Preventive maintenance. Predictive maintenance using sensor data. Corrective maintenance after a fault is detected. Lecture 8, Environmental Protection and Risk Management. Offshore operations must be environmentally sound and sustainable. 8.1 Pollution Risks. Oil spills. Chemical discharges. Waste handling. 8.2 Prevention and Mitigation. Double-hull tankers. Zero discharge policies. Oil spill response equipment. Blowout contingency plans. 8.3 Regulatory Framework. MAPO. OSPA Convention. Local regulatory bodies, e.g., NUPRC in Nigeria. Lecture 9, Future of Offshore Technology. As we move into deeper waters and more complex fields, offshore technology continues to evolve. 9.1 Trends. Floating production storage and offloading, FPSO. Subsea factories with fully autonomous systems. Digital twins and AI for performance optimization. 9.2 Deepwater and ultra-deepwater. Water depths exceeding 1500 meters. Use of advanced riser systems and remote control. Improved materials for high pressure and temperature. 9.3 Renewable integration. Offshore wind farms sharing infrastructure with oil platforms. Hybrid systems with energy storage. Module 2 Summary. In this module, we have explored 1. The step-by-step drilling operation sequence for offshore wells. 2. Principles and equipment behind well control operations. 3. The intricacies of subsea well completions. 4. Design and operation of subsea production systems. 5. Monitoring, control, and maintenance of offshore facilities. 6. Challenges and solutions in flow assurance. 7. Environmental management and emerging technologies shaping the future.